The James Webb Space Telescope, unlocking the secrets of the universe. The James Webb Space Telescope, JWST, is a large, infrared-optimized space telescope that is set to be launched in 2021. It is the successor to the Hubble Space Telescope and is considered to be one of the most ambitious astronomical projects ever undertaken. The JWST is a collaboration between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. The main science goals of the JWST are to study the early universe, the formation of galaxies and stars, and the formation and evolution of planetary systems. It will also study the physical and chemical properties of the universe's first galaxies, stars, and planetary systems. The telescope will be able to observe some of the most distant objects in the universe, as well as objects that are too cool to be detected by current telescopes. One of the key features of the JWST is its large primary mirror, which has a diameter of 6.5 meters. This is more than twice the size of the primary mirror of the Hubble Space Telescope, and allows the JWST to collect significantly more light. This increased light-gathering capability is particularly important for studying distant and faint objects in the universe. The mirror is made up of 18 hexagonal mirror segments that are coated with a thin layer of gold to increase their reflectivity. The JWST also features an innovative sun shield that will protect the telescope from the heat of the sun. The sun shield is made up of 5 layers of a special material called Captain, which is highly heat-resistant. The sun shield will keep the temperature of the telescope at around 50 Kelvin, minus 223 degrees Celsius or minus 369 degrees Fahrenheit, which is cold enough for the telescope to observe in the infrared part of the spectrum. The JWST will be launched into space on an Ariane 5 rocket from the European spaceport in French Guiana. Once in orbit, the JWST will be positioned at the second Lagrange point, L2, which is located 1.5 million kilometers, about 930,000 miles, from Earth. This location will allow the JWST to observe the sky continuously and without interruption from the glare of the Sun, Moon, or Earth. The JWST is equipped with 4 main scientific instruments: the Near-Infrared Camera, NIR-CAM, the Near-Infrared Spectrograph, NIR-SPEC, the Mid-Infrared Instrument, MIRI, and the Fine Guidance Sensor / Near-Infrared Imager and Slitless Spectrograph, FGS/NIRIS. These instruments will work together to observe the universe in infrared light, from the near-infrared to the mid-infrared. The NIR-CAM will be used to study the early universe and the formation of the first galaxies, stars, and planetary systems. It will also be used to study the physical and chemical properties of these objects. The NIR-SPEC will be used to study the properties of individual stars, galaxies, and other objects in the universe. It will also be used to study the properties of the interstellar medium, which is the matter and radiation that exists between stars. The MIRI will be used to study the properties of cool objects in the universe, such as brown dwarfs and exoplanets. It will also be used to study the properties of the interstellar medium and the early universe. The James Webb Space Telescope, JWST, has undergone a number of key milestones in its development, including 1996, NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, begin planning for the JWST. 2002, NASA selects the design for the JWST, which includes a large primary mirror and a sun shield to protect the telescope from the heat of the sun. 2007, the JWST's primary mirror is completed and the first set of mirror segments are delivered to NASA. 2011, the sun shield for the JWST is completed and delivered to NASA. 2013, the JWST's scientific instruments are integrated into the telescope structure. 2016, the JWST undergoes its first cryogenic testing, where it is cooled down to its operating temperature of 50 Kelvin, minus 223 degrees Celsius or minus 369 degrees Fahrenheit, to ensure that it can function properly in space. 2018, the JWST undergoes its final integrated testing before launch. 2021, the JWST is scheduled to be launched into space on an Ariane 5 rocket from the European spaceport in French Guiana. The James Webb Space Telescope, JWST, is a collaboration between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, and many scientists, engineers, and technicians have been involved in its development. Here are a few key scientists who have played important roles in the project. Matt Mountain, who is the current director of the Space Telescope Science Institute, STSCI, and former director of the Association of Universities for Research in Astronomy, AURA, served as the JWST project scientist from its inception until 2014. Matt Greenhouse, who is currently the project scientist for the JWST at NASA's Goddard Space Flight Center, has played a key role in the development of the telescope's scientific instruments and the planning of its observations. John Mather, who is a senior astrophysicist at NASA's Goddard Space Flight Center and a senior project scientist for the JWST, shared the 2006 Nobel Prize in Physics for his work on the Cosmic Background Explorer (COBE) satellite. Also, he was a key player in the development of the JWST's science goals and instruments. Jean-Luc Buzet, who is an astronomer at the French National Centre for Scientific Research, CNRS, and the director of the Grenoble Institute of Planetology and Astrophysics, IPAG, has played a key role in the development of the JWST's NIR-SPEC instrument, which will be used to study the properties of individual stars, galaxies, and other objects in the universe. Gillian Wright, who is an astronomer at the UK Astronomy Technology Centre, has played a key role in the development of the JWST's MIRI instrument, which will be used to study cool objects in the universe, such as brown dwarfs and exoplanets. Pierre Ferraud, who is an astronomer at the European Space Research and Technology Centre, ESTEC, has played a key role in the development of the JWST's NIR-CHEM and FGS/NIRIS instruments. It's worth noting that this is not an exhaustive list, and many other scientists, engineers, and technicians have also played important roles in the development of the James Webb Space Telescope. Here are a few examples of the types of discoveries that the JWST is expected to make. The early universe, the JWST will be able to study some of the most distant objects in the universe, including the first galaxies, stars, and quasars. This will allow scientists to learn more about the early universe and the conditions that existed soon after the Big Bang. The formation of stars and galaxies, the JWST will be able to study the formation and evolution of stars and galaxies in unprecedented detail. This will allow scientists to understand how these objects formed and evolved over time, and how they have contributed to the structure of the universe we see today. The study of exoplanets and planetary systems, the JWST will be able to study the physical and chemical properties of exoplanets, including their atmospheres, temperatures, and compositions. This will allow scientists to understand how these planets formed and evolved, and whether they could be habitable. The study of the interstellar medium, the JWST will be able to study the properties of the interstellar medium, which is the matter and radiation that exists between stars. This will allow scientists to understand how stars and galaxies interact with their surroundings, and how they influence the overall structure of the universe. The study of cool objects in the universe, the JWST will be able to study cool objects in the universe, such as brown dwarfs and exoplanets. This will allow scientists to understand how these objects formed and evolved, and whether they could be potential places to search for life. It's worth noting that these are just a few examples of the types of discoveries that the JWST is expected to make, and the telescope's capabilities are likely to uncover many other unexpected findings as well. Thank you for watching. Subscribe InfoGrid and click the bell icon for more educational videos.